Hi, my name is Emma Magnuski, and this is a video explanation of me modeling positive and negative numbers. It is part of a video assignment for my mathematics for teacher courses at Bridgewater State University. So right now I'm modeling positive and negative numbers using two color chips. So the positive will be yellow and the negative will be red. So the first number we'll be modeling is 4. So to do number 4, we can put 4 yellow chips. 1, 2, 3, 4. That's the number 4. There are 4 positives. Positive, 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 and a positive. And to write 4 a different way could be 4 positives, just like we have in that bubble. And then, oh, that one went somewhere. So 4 positive chips, which are yellow. And if we added a negative chip, which would be red, that would make it 3. So therefore, we would need another yellow chip to cancel out. So this right here makes 0, and this would make 4 positive chips. So this is 4 positive chips with just 4 yellow positive chips, and this is 4 positive chips and then a set of a positive and a negative to cancel out to make 0, making it the number 4. So the magnitude of this from 0 would be 4. So the magnitude is pretty much with the starting point to that number and how many spots it takes. So if we clear all this and get 2 more up here, and say we did -5. So -5 is on the right side of the number line. And -5, you could model it with 1, 2, 3, 4, 5 negative chips. And for an alternative way, could be the same as the positive 4. 1, 2, 3, 4, 5 negative chips. But if you have the added set with a 6th negative followed by yellow, this portion is 0. So here you have 1, 2, 3, 4, 5 negatives, which is that. And here you have 1, 2, 3, 4, 5, 6 negatives with an additive positive, which still makes it -5. And so the magnitude of this is the absolute value of the unit, which pretty much is just the value of the unit. So for -5, the magnitude would just be 5 away from 0. This is using the 2 color chips. Now for the same example using the number line. So here we have, let's see, the number 4. So we're trying to get to 4, right? So we have the number 4, and we would move 1, 2, 3, 4 spots. That's 1, 2, 3, 4 spots from 0, 4 positive spots in this direction. And that makes 4. And the magnitude would be, if you can tell from here, would be 1, 2, 3, 4 to the number 4. Now, if we did the number 5, it's easier to see on a number line, I feel. It would be 1 this way, another one, another jump to -3, another jump to -4, and another jump to -5. So this is 1, 2, 3, 4, 5 jumps to the -5, moving in the left direction on the number line to get to -5, and that means the magnitude would be the number 5 for this, because we're moving only 1, 2, 3, 4, 5 spaces in the negative direction, but if you remember, it's the absolute value. Lastly, for our online models, we're going to use the algebra blocks. So we need to get the number 4 again, 2 ways. So in order to get the number 4 2 ways, we have 1. So if the yellow is the same thing, so 1, 2, 3, 4. That's 4 positive yellow blocks. 1, 2, 3, 4. That is the 4. For the magnitude of the unit from 0 is 4. Now, if we were to have a second set, again, 3, 4. Say we had 6. So this would equal 6 right now. So this equals 6. But if we had a -1 and a -1, these would cancel out and you would be left with 4. Pretty much the same as the chips. These two cancel, a positive and a negative cancel. So for here, a positive and a negative cancel. If we were to go for a -5, if we had 1, 2, let's see, we move this over here, 1, 2, 3, 4, 5. That is one example of -5. But because if you count, just counting the blocks, 1, 2, 3, 4, 5, there are 5 blocks making the magnitude 5. Say we had another set of blocks for a second example, 1, 2, 3, 4, 5. And say we had, I don't know, 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we have 9. So in order to get just -5, we'd have to add 1, 2, 3, 4 to cancel out. And so we have put a line here. And if you count 1, 2, 3, 4, and 5, we get -5, and these would just cancel out. Alrighty, that's it for our online examples. Now, for real life examples, if we had money, for example. So say you had 4 $1 bills. 1, 2, 3, and a 4th one, 4. If you counted to 4, if you said to your friend, I have 4 $1 bills. 1, 2, 3, 4. That's 4 $1 bills, which equals 4. This would be a magnitude, because if you start with no dollar bills, if you had 0, you would have 0. But now if you say you have 1, 2, 3, 4 dollar bills in total, the magnitude is $4. -5 is a little trickier. It's a hard concept because when you have $0, you actually have no physical dollars in your hand. But say you went to go pay for a pair of shoes, and those shoes were $10, right? And you only had a $5 bill. Okay? So you start with a positive balance of $5. So if you had only $5 and you subtracted the 10, you would get -$5 that you still owe. So this is -$5. So you are, we would say, in the real world, in debt by $5. So if you had, let's say, $5, we're just going to use little squares, 1, 2, 3, 4, 5, and you subtracted 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you shade these in, 1, 2, 3, 4, 5. So subtracted by 10, 1, 2, 3, 4, 5. you still have this whole group of $5, which is negative $5 that you still owe. So if you count 1, 2, 3, 4, 5, it means you have a magnitude of 5 for the negative 5. This has been my examples for positive and negative numbers using positive 4 and negative 5 for various methods. Thanks for watching.